Hi everyone. So this is my presentation on how land cover and soil affects infiltration and runoff. So I asked, how does that affect it? And I thought the first thing I thought of was creating a small ecosystem that you can do in the classroom. I did it outside, just you know, dirty, but it's something we can do inside the classroom. To do this, I went to the dollar store. I got four tinfoil pans. I got two 9 by 13s and two turkey size pans. And I wanted to create two separate ecosystems to see the different effects. I used one that was just soil, and then I did one that was land cover and soil, and I used Colby filters as a form of land cover. Before filling these, I did poke holes in the bottom so that when I poured the quote unquote rain over it, it had place to go. The runoff could actually drip through and wouldn't just soak in the pan. I placed these ecosystem pans inside the turkey size pans so that when the runoff was occurring, the infiltration, it was dripping down to a whole nother pan and there was a couple inches separating the two. So I could see the drips and I could see the depth of the runoff. And to create the rain effect, I got a plastic cup and I poked against some holes in the bottom with a pencil and poured it with water and kind of drizzled it over it to make it seem like a rain effect. After completing the experiment, I think it'll be interesting to use different types of quote unquote land cover rather than just coffee filters. That's just what came to my mind. Because obviously there's different land covers in the real world. So there's more than just coffee filters. They could use actual grass, maybe leaves. They could use paper, I was thinking. Let the students get creative and they can probably think of all different things. I would also like to include a timing component. The soil, when I first started wetting it, was quick to drip through and fill in the bottom. But over time, as the soil got wet, it slowed down. And the ecosystem with the land cover and soil was just a slower drip off altogether. So that was kind of an interesting thing, and that could entail more math. I could make a graph, a scatter plot, see how that affected it. Also, for time's sake, if I were to do this in the classroom, I did put a lot of soil in mine. I put about 4 inches. I think I would maybe narrow it down to about 2 inches, so you still have some thickness, but it doesn't take as long for it to soak through and see the effects. But again, I could maybe do one ecosystem of 4 inches, one of 2 inches, and use that as a comparative and see how that affects it. So going through PA Steels, I found at least 3 standards alignments to what I did and how it could be used in conjunction. So develop a model, describe how watersheds and wetlands function as systems. So obviously it wasn't a wetland, but how the watersheds, how they all run off. And again, using different land covers that could affect where the water goes and how much it goes. Second one, apply technology and engineer and design thinking process. So I was very basic with mine, but I think some of the students could get a little bit more creative in how they go about creating and implementing the ecosystem and the rainfall. And then finally, refine design solutions to address criteria and constraints. So after looking back, how I said maybe I would add a timing component, doing the 2 inch versus 4 inch, using different land covers, we could give our students a handful of questions to get more specific on how they affect the runoff and infiltration. And then finally, comparing it to Vasquez's model. For science, they plan and carry out investigations. So again, how does it affect it? How could we do it? So this was just my idea. I bet if I gave this to students, some of them would get creative and come up with a different way to see how soil and land cover affect runoff. The engineering aspect, I said engage in argument from evidence. Looking at the runoff, what color was it? How much was it? Was it a good thing? Was it a bad thing? And if we thought it was a bad thing, what could we do to make it better, make it clearer, make it more runoff, less runoff, and so on? For the technology, make informed decisions about technology given its relationships in society and environment. Again, there might be some land covers that could have a positive or negative effect on the runoff. So what are they? Are there things that we can man-make to help or maybe improve what there already is, maybe to increase it or get rid of it, use technology in that aspect? And then finally, for math, reason abstractly and quantitatively. reflect on the amount of runoff. So in each one, compare that, how much time it took, like I said, to add a timing component to see how long it took for it to soak through the soil and the land cover. And as I said, we could also create a graph with this and compare the data that way. So this is my first attempt at a STEM-based lesson from start to beginning on my own. So hopefully